The purpose of this screencast is to show how to do correlation and regression using Statkey. So we'll take this as our question. What is the correlation coefficient between the size of houses in Winona, Wisconsin, and their price? Size will be our explanatory variable. Price will be the response variable. And then once we have the correlation coefficient, we'll ask, what is the equation of the least squares regression line? And once we have those things, we want to see how to interpret them and how to use them. So we're looking at Winona, Wisconsin, and the relationship between size. By size, I mean how many square feet the house has. Finished square feet. And so the relationship between size and price. Okay, so we go to Dane County Homes data, and we go to the sheet for Winona, and column B has the price, and column F has the size, so I'll copy that, and I'm going to put them into their own spreadsheet, so they'll be side by side with each other, which is where we need them for Statkey. And Statkey does not like dollar signs and commas, so to get rid of those, I go up here and I choose general format. So make sure that the numerical format is called general, and now I've got the same numbers but no commas, no dollar signs. And I grab those two columns and I go to Statkey. So I've copied them and I'm going to paste them into Statkey. Now the size of a house and the price of a house are both quantitative variables, so I've got two quantitative variables. I'm trying to understand how they're related to each other, how you can use one to predict the other. So I click on the two quantitative variables, I get rid of the data that's in there, just X all that out, and copy my data in. And at the top I've got those labels, price and finished square feet, so the data does have a header row. And then I click OK, and this is almost exactly what I want, except we see price on the x-axis and for total finished square feet on the y-axis. But I want those two switched around. The reason is I'm trying to use the size, the finished square feet, to explain the price, to predict the price. So the problem told us that total finished square feet would be the explanatory variable, and the explanatory variable always goes on the x-axis, on the horizontal. And the response variable, the price, goes on the y-axis, the vertical. So I just switched the variables. Okay, and now my summary over here tells me the correlation coefficient, 0.852. So what's the correlation coefficient? 0.852. What's the interpretation? This is strong because it's close to 1, and positive because it's greater than 0. What that means is the larger the house, the more it costs. Not very surprising, but it tells us that knowing the size of a house does quite a good job of predicting its price in Winona. Strong because it's close to +1, positive because it's positive. Okay, so now what's the equation of that least squares regression line? Go back to Statkey. First of all, we can just click here to show the line. So this is the line that fits the data best. There's no one straight line that goes through all those points, of course, but this is the one that fits it best. The slope is 330, and the intercept is negative 335,500. So that means the equation of the line is predicted price equals, what was that? 330 times size minus 335,500. Or another format for the same thing, we'll use the formal symbols. Y hat. So the hat means that it's not the price, but the predicted price, equals 330x minus 335,500. Y hat equals 330x minus 335,500. And then when we write it this way, we need to identify our variables. X equals size in square feet. Y hat equals price. Y hat equals price in dollars. What that means is that if we want to predict the price of a house in Monona coming onto the market, we would take 330 times the size and subtract 335,500. So as an example, suppose we had a 2,000 square foot house, then the predicted price would be 330 times 2,000, if there's 2,000 square feet in the house, minus 335,500. And on my calculator, that works out to 335,500. That works out to $324,500. Let's go a little bit further. What is the interpretation of the slope? Well, what is the slope of this line? The slope of this line is 330. What does the slope tell us? It tells us how much the output changes when the input changes by 1. For every additional square foot a house has, its predicted price increases by $330. And this doesn't mean that if you come along and build one additional square foot on a house, its predicted price goes up. It just means that when you're comparing two houses to each other, for each additional square foot, the predicted price increases by $330. How about the intercept? Well, this has no reasonable interpretation. The intercept is trying to tell us what the output is when the input is 0. So it would be trying to tell us the predicted price of a 0 square foot house. But there's no such thing as a 0 square foot house. And for sure, you're not going to be able, no one's going to give you $335,500 in return for buying a 0 square foot house. It just doesn't make sense. So this is one of those cases where the intercept doesn't have a reasonable interpretation. The slope almost always does. So the important thing here, though, is just to get comfortable with Statkey. You grab the data. You need 2 columns of quantitative data. Copy, paste them into Excel. Switch the variables if you need to get the order of your variables right, to get your explanatory variable on the x-axis. And then you can read the correlation coefficient here, and then the equation of the line. Here's the slope, here's the intercept.